Welcome to one more session. How are you all doing? I hope you are doing great. You're taking care of your health, your safety measures, and everything. And let's get started. In this video, today we're gonna have a look into art programming basics, how art programming is different from other programming languages, a quick introduction, and then also we're gonna take a look into Art Studio, and we'll try to see how do you start working on Art Studio. The download link for Art Studio and are gonna be there in the description. Enjoy the video, stay tuned. So let's see what is R and what all we need to know to start getting on art programming. There are going to be multiple features which are very similar to Python, and there are multiple reasons where people prefer Python over R, but in this discussion we are not going or discussing about the comparison. For the comparison, we're going to have a separate video. So let's get it started and let's see what is R. Now, as a programming language, R is used for two major purposes. One is the statistical analysis, and secondly, for data visualization or data representation. Now, when I talk about the benefits of R, R has a very rich set of library, and in this library are some set of ready-made code where we can directly go and use those functions and get the code running without much of deliberations on writing our own codes. Now, these libraries are primarily written in C, C++. Some of the components are also written in Fortran. Some of the components also we see are written in .NET. And surprisingly, some of the components of R are also written in Python. So when this all got started, who started this and how does this actually get generated? Who is handling R? Who actually built the libraries for R? Let us answer a few of those questions. The programming language R got invented or actually get popularized in 1993 by two programmers, or we should say two statisticians named Ross Yahaka, and the second one person responsible for that was Robert Gentleman. Now, identically, there are multiple theories how the name R came from, but there is a significant coincidence to observe here that both the people who are behind the innovations of R, their name starts with R, right? So these two people used to work in the Department of Statistics in University of Auckland in Auckland, New Zealand. And they came forward and said, guys, we do have a set of open source code to be shared with you, which is rich in significant libraries, and you can just get it started writing your own code. Then what happens? Multiple people, they said this is gonna be open source. So if you have worked on R and you have made a very cool library function which can automate a lot of analytics or analytical process, please come ahead. Please come forward and share with the art team. Now, as this community keeps on growing, many people started coming forward. They understand that yes, this complete library or the packages, everything cannot be handled by only two people. So in the year of 1997, they created a group called R Core Team. And then onwards, they started managing the complete repository for the R source code. The advantage of using R lies here, as this is an open source and there is a group of people who is actually validating whether this code should go into the library or not, whether it should be published for a library or public or not. Significantly, that creates a lot of benefit. So you get a code written for every purpose available to you, and which is also moderated by a group of people. Now, talking about some couple of benefits of R, whatever you expect from a good programming language, everything is available in R. Is it simple? Yes, it is very simple. It is as simple that as we are talking in English. Can we do have all the basic functionalities of programming like loops? Can I do conditional forwarding or conditional statements? Can we also have the primitive data types such as array? Can I also have list? Can I also have dictionary? Can I also have vectors? Yes, so those all are possible here, right? So what are the standard functionalities of a programming language? Everything comes down here. Is it good in managing the data? Yes, absolutely. R is phenomenal in handling large data. Of course, R is also been blamed to be a little more memory hungry than the other parallel programming languages, but nevertheless, it do the work. Can I also integrate R with other tools where it can actually read the data from different web applications or web services and directly generate the result for me on the runtime? Is it possible? The answer is yes, it is possible. R is highly integratable or integrable with other web services or the other standard tools. And last but not the least, do I get a graphical facility or graphical interface to deal with that or to represent my data in form of graph, which we call visualization. R also is capable of providing a UI interface and the visualization of the data. So now to summarize quickly, R is simple to understand and learn. R accommodate all the standard programming features. R is good in handling large amount of data. R is also compatible in getting integrated with other applications or web services. And the data visualization is also possible in case of R. So that basically summarizes what is R and how is basically gonna work out. All right, so this is the R Studio, where from you can use the benefit of a phenomenal programming language, and as well as you can also use the benefit of word processor kind of an interface where you can move the cursor very easily, select, cut, copy, paste your codes, comment your code, and write a set of lines at the same point of time instead of executing the code. Now, once we are in this interface, first of all, we're going to go to File and create a new file. So once I am at file, I'm gonna go to new file and I'm gonna choose R script. Once that I'm at R script, I'm gonna realize the screen is actually broken into 4 parts. So let me understand what are those 4 parts and what are the names. The first component here, this is known as the code editor. So whatever script or the code you wanted to write actually goes here. Exactly below that, this part is called as the console or the terminal, where the outcomes or the results of your code gonna get displayed here. Subsequently, on the top right side, you're gonna have 3 options or 3 submenus. The first one gonna be called environment. So whatever the variables or the data items we create, all gonna appear here. The second tab is history, where whatever the commands you have executed will be appearing here. If you don't want something to be permanently there in the history, you're gonna click on this broom sign and that's gonna get deleted. And then finally, the connection tab, where if you wanted to fetch the data from a very specific source, data source, or some other application, you're gonna define that or define those connections here. Also, bottom of that, you'll be having a total of 5 submenus. The first one is files, where if you have some specific files mapped to your workspace, those will be available here. We're gonna have the second one, plots. So whatever graphs you are generating, gonna be available here. And after generating a specific graph, if you wanted to export the graph for your documentation purpose, you can click on export and choose save as image, or you can also save as a PDF. Now, as there are a lot many packages and every single day new packages keep on coming for R, all those packages which are not by default installed in R can be searched here, and you can use the search box here to install any of the specific package. You have a help option as well here. Now, if at all I type some of the help components here for which I wanted to know more, and the detailed help will be displayed here. For a matter of fact, being an open source tool, R comes with a very significant and very good help support. And the final option is a viewer. So if at all some sort of visualizations or a process flow or a model, what you have just now built and wanted to see how that particular model is actually working on, you can always go ahead and check in the viewer option. So now let's get it started and see what all we're supposed to do and what are the basic functionalities we can do it on R. So in this tutorial, we're gonna learn some of the basic components which are gonna be useful for any of your R scripting classes. And we're gonna understand how to deal with the workspaces also. So let us get started and try to understand some of the very functional features of R. First thing first, if at all I have to comment any of the lines in my code or add some comments, I'm gonna go ahead and use the symbol hash. So I'm gonna first demonstrate some of the basic arithmetic operation. So I'm gonna write arith syntaxes. So this will define me the arithmetic syntaxes. Now, by this time, you might have noticed the name of this document panel became in red and it is coming up with a star. That means you do have some of the code in your code editor which is not saved yet. So what you're gonna do, you're gonna click on this save button and save the document with a .r extension. So we're gonna call it sample.r. The extension .r does not matter. It can be uppercase or lowercase, but just ensure that you are saving this code with a dot or extension. Otherwise, next time when you have to load this code in the code editor or in the RStudio, it's gonna be a problem, right? So let's click on save and move forward. Now the basic arithmetic operation, I can perform a addition operation here, which can be as simple as 1 plus 2. And I can go ahead and select the complete line and then click on this run button. Or as the tooltip is right now showing, I can also hold the control key and hit enter to execute one or multiple lines from the syntax. So I'm just executing one simple code now. So I'll select the line because this is the only one line I wanted to execute now. And I'll hold the control key and hit my enter. Now we're going to see in the console, I got the result for it. So what are the other symbols I can use? I can always go ahead and use a multiplication operation. I can also go ahead and use a divide operation. I can also go ahead and use something which I called a modulo operation, where I can say 10 modulo or remainder 2. So if at all I divide 10 by 2, what left out? Actually nothing. So that's what is 0 here. Now, so I can also write these codes in the terminal or in the console, or I can assign these variable values or these values or this equation values into some variable. But we'll take a look into that in a while. Now let's see how do you generate an output statement which is meaningful and understandable by the end user or the customer. So if at all I wanted to write hello world, I can also just go ahead and say double quote hello world. And I can select that and get it executed. So hello worlds comes in the console window. I can also use the print function, which is called print, not printf, as simple as that. And once I write down any standard functions, you can also see the tooltip is popped out and the code autocomplete is also loaded. So syntax is not that crucial here because you can always get some help from this. Now I'm gonna write the same syntax once again, and I'm gonna say hello world from print function. And then I'm gonna select that code and get it executed. Point to be observed here, there is no termination syntax like a semicolon or a comma or a dot at the end of the R syntaxes. This is as simple as a statement without any end termination character. Now, printf can be limited in certain features, which always can be replaced by sprintf, where I wanted to use sprintf a text to be printed along with some other variable where the value of the variable should be randomly evaluated. So those components I can always do here. And this time I'm gonna say inside a double quote, I'm gonna say hello world from sprintf function. Once again, I'm gonna select this code and I'm gonna either click on this run button or I can hold the control key and hit enter. Right, so that's probably brings us to basic representations and the basic awareness of R. We're gonna quickly take a look, how do I define certain parameter characteristics, some generic variable values, and get it loaded. Now, in case of R, the variables are not strongly casted. That means I don't have to specify always the fixed storage type or the type for the variable. So if at all I wanted to define one variable called data, I don't add anything before the variable name, just the name of the variable, and the data type of this variable will be decided on the type of data we are assigning to that. And how do I store a value? I put a reverse arrow towards the variable name, and then whatever the value I wanted to assign, I just write that value. That's how I gonna define the or initialize any variable in R. How do I get an output from this variable? If at all this variable has been a while and then I wanted to know what does happen with this variable and what is the value stored in this variable. I can go ahead and as easily write down the name of the variable data, and then it will get me an output of 10. If at all I am not very comfortable in using data as a simple text, I can always go ahead and write print data. And the moment I execute this, I'm gonna get my output here. And now if at all I want not this particular data, I want to also display a meaningful information while this data is actually being displayed, I can always use sprintf. And let me write a text here. The value of the variable data is equal to %d at this time. And that will tell me where exactly the data is to be printed at what situation, right? Now, I have to put a comma here and write the name of the variable so that this variable value can be evaluated on the runtime and can get printed here. So let me run this code and see the value of the variable data is equal to 10 at this time. So that makes a lot of benefit for the end user to understand the code. R is also very good in handling the dynamic nature of the logical expressions. If at all I go ahead and say print, and inside that if I say a is less than 2, and if I go ahead and execute this statement, as 1 is actually less than 2, I'm getting a true value printed here, which makes a lot of advantage. I can replace these numbers 1 and 2 by variables or by expressions. I can say if at all the variable data is actually less than 2, and if this time I'm going to execute this code, eventually it will show me false because data is 10. So these benefits are also available. Now, let me take your attention back to this environment here. As I was mentioning, which all variable gonna get created here, all these variables will be listed here. So now data is listed and the value of this particular variable 10 is also printed here. So at any point of time, if you wanted to know, if you have hundreds of variables and if you wanted to know which variable holds a specific data, you can actually trace it out from here. Instead of giving a dummy value to the variable and then testing, you can always test the progress here. Now, there are a couple of other things where you have to where you can also get the benefit. There is one function which is called ls, or stand for list. If I go ahead and execute this command ls, I'll be able to know which all variables are right now in my data sources or in my workspace. If at all I wanted to remove any of the particular variable from the complete workspace for some reason, I'm going to use a command called rm and I'm going to name the variable which is to be deleted. I can also, if at all I do have hundreds of variables here, and then those 100 variables cannot be deleted by rm command, because in that case I have to execute 100 rm commands for a matter of fact. So what I'm going to do, I'm going to create another variable which is called list, And inside list, I'm gonna have one syntax called ls. So once I execute this code, what I'm gonna have, list gonna have all the variables in my workspace. So as you can see, I can assign the value inside a variable from a function or from a expression as well. Right? And there, in this case, I have used an equal sign just to eventually demonstrate to you that not only a reverse arrow, or rather a equal sign or assignment sign can also be used for these purposes. There are some advantages of using the reverse arrow. We will also try to see that in a later state. Now, if at all I wanted to see how many variables are there, I can execute the list variable, or I can print or sprintf list. And now, if at all I wanted to delete all these variables at the same point of time, I'm gonna say list or rm, and inside bracket, I'm gonna say list. So what happens now, this method, the moment it gets executed, it deletes all the variables which is part of list. That is nothing but the variables which is available in the workspace. R also comes with a very big advantage of merging the code into a single line, where you can summarize these 3 lines inside a single command. Like, for example, I can say rm, where I can say list is equal to ls. Now, what this code will do, this code will first generate the list, assign the list of variable in the list, and then rm will take care of that variables and everything will be deleted. So let's execute that and find out what happens. And by the time, we'll also keep our watch on this environment tab and see what happens. So I'm gonna select this complete code, hit Control Enter. Everything got deleted, code executed successfully, and I'll see my environment is now empty, because how many variables I might have, everything could be deleted with a single command. Well, that brings us to the end of one more session. Hope you have understood and realized how to work with R, what are the fundamental commands, and you might have also understood how to use RStudio effectively, professionally. Well, see you then once again in the next video. Till time, stay safe, stay tuned.